How do you find the domain of a function? First of all, you should have been introduced to functions and function notation in previous math classes, and you should be aware of the fact that we have a domain, which is usually the set of the x values, and we have the range, which is usually the set of the y values. And recall, we also had what was called the vertical line test to determine if the graph was a function. Usually, the implied domain is all real numbers, and that's true for polynomial functions. However, what about rational functions? This is where you are dividing two polynomial functions, and since you're dividing, there's a denominator involved. And you should all remember that you cannot divide by 0. That's undefined. And so, if we have some values of x that would cause the denominator to be 0, those cannot be part of our domain. And so in order to find the domain, you would set the denominator not equal to 0 and solve. You might also recall that's where you're going to also find those vertical asymptotes. The other type of function we're going to be looking at are radical functions. If you have an even root, like the square root of a negative number, that's imaginary, and we are dealing with real valued functions, and so we cannot have values of x that would cause the function to become imaginary. And so if we have a radical function, you set the radicand greater than or equal to 0. The radicand is the thing that's underneath the radical, and you set it greater than or equal to 0 and solve for x, and those are going to be the values that are acceptable. A lot of this should be a review from college algebra, but we are going to be looking at probably more difficult problems. Now what I have done is I've gone through and gotten screenshots of these graphs so you can see how the domain found algebraically relates to the graph. You're still going to have to show your work algebraically, but you could check it with a graphing calculator to see if it lines up. Alright, so number one, we have a rational function. You have a denominator that involves x, and so we want to set that denominator not equal to 0, just like here, and solve for x. So yes, you're going to need to factor, set each factor not equal to 0, and solve for x. Now what that says is that the domain is all real numbers except 3 and negative 2. And if you come and look at this graph, there's a vertical asymptote right at 3 and right at negative 2. So all real numbers except 3 and negative 2 would be the domain. Look at this one. Again, we have the denominator. Do not worry about the numerator. That can be 0. Just the denominator cannot be 0. So we set this not equal to 0 and solve for x. Now this you cannot factor. You just add 5 to each side, take the square root, and don't forget your plus or minus sign. Now the square root of 5 is a little bit bigger than 2. So you can kind of come over here and say, yes, there's vertical asymptotes somewhere between 2 and 3. That just verifies that algebra. Let's look at this third example, much like the second one. You're going to set the denominator not equal to 0. So we're going to add 6 and divide by 8. I'm going to reduce that and then take the square root. Don't forget your plus or minus sign. And again, I'm not too sure exactly what that is, but this looks like, yes, I would have 2 vertical asymptotes, and you could punch that into the calculator and look at the decimal approximation. But one thing the graph does verify, that in all 3 of these examples, we had 2 values that were excluded from the domain. So remember, the domain here is all reals except 3 and negative 2. But you can write it like this, and that's what that means, alright? So all reals except plus or minus the square root of 3 over 2. All reals except plus or minus the square root of 5. Now those were kind of easy. Let's see how they get more difficult. Let's look at these square roots. Right. You have to set the radicand, the part that's underneath the radical, greater than or equal to 0, and solve for x. Now that looks pretty easy. Subtract 2 and divide by 3. Well, if you look at here, this is negative 1. That looks like negative 2/3, and the graph is only greater than or equal to negative 2/3. That is the domain. Now you need to write your answer in what's called interval notation. And again, you should have learned that in a previous math class. We have bracket, negative 2/3 to infinity. And that's exactly what that graph gives us. Now number 5 is more difficult because of the fraction. So that whole thing is underneath the radical. And we have to set that greater than or equal to 0. You cannot cross multiply and get rid of that fraction. You have to think about, when is a fraction greater than 0? When is it positive? Well, the only time it's positive is when the numerator is positive and the denominator is positive. Or they're both negative, because a negative over a negative is a positive. Any other combination is going to give you a negative number, which is less than 0. So how do we solve that? Looking at that picture sure doesn't help. Well, you're going to take the top part and set that equal to 0 and solve for x. And then you're going to take the bottom part, remembering just what we did on the first examples, that the bottom cannot equal to 0. We're going to say not equals to 0. And so I know there's a vertical asymptote at x is equal to 2, which certainly does match my picture. But again, that's not the domain. How do you put that together? Do a number line. Okay, this can equal to negative 1/3, so I'm going to put a filled in dot. That cannot equal to 2, so I'm going to put an open circle. And then I'm going to test points in each interval. So I'm going to pick, say, a -1, a 0, and a 3, and I'm going to plug it back in there and see, do I get a number greater than 0? So if I plug in -1, 3 times -1 plus 1 over -1 minus 2. Well, let's see, -3 plus 1, that's -2 over -3, which is positive, so that's good. If I put in 0, 3 times 0 plus 1 over 0 minus 2. Well, that's 1 over -2, that's negative. That doesn't work. If I put in 3, that's 10 over 1, that's positive. So that means those values are good and these values are good. And so my domain is from negative infinity to negative 1/3 bracket union with parenthesis 2 to infinity. And again, if I look back up here, that looks like negative 1/3. It goes on forever there. And here probably goes on from 2 and beyond. But again, it can't be 2 because that was in the denominator. Number 6. This is a little bit easier than number 5. We only have the denominator to worry about. So let's see. That's a radicand and it has to be greater than or equal to 0. But wait, it's in the denominator. So it cannot equal to 0. So we're going to take that part away. It can only be greater than 0. So again, solving for x, pretty easy. Greater than -3/2, greater than -1.5. That looks pretty right. So how would we write that in interval notation? Parenthesis, -3/2 to infinity. Now number 7 is harder. There's no really shortcuts. The graph does help, but this is what you've got to do. Got to set that greater than or equal to 0. You have to factor that. You've got to learn how to factor. I believe that is correct. All right, so now I'm going to set each factor equal to 0. You cannot put greater than 0. That does not work. I'm going to explain in just a minute. So let's set those equal to 0 and solve for x. Those are where this makes this equal to 0. When is it greater than 0? Well, if you come back up here, when you multiply two things, how do you make it greater than 0? They either both have to be positive, because a positive times a positive is a positive, or they both have to be negative, very much like the division. So we're going to do a number line, and these can both equal to 0. They're not in the denominator. And again, we're going to do some test points. So let's see, I'm going to pick -1, that's easy, 0, and how about 2? Now you can plug it into here, but I'm going to choose there because to me that's easier math. If I plug in -1, I'm going to get -3 plus 2, which is -1. And then that's -2 minus 3, which is -5, which is +5, which is greater than 0. So that counts. If I put in 0 here, I'm going to get 2 times -3, which is -6. That's not greater than 0. If I plug in 2, I'm going to get 6 plus 2, that's 8. 4 minus 3 is 1. That's definitely positive. So I have a domain from -infinity to -2/3 bracket 3/2 to infinity. Now anytime you graph that on the graphing calculator, it just doesn't quite, even if you zoom in, it doesn't quite get down here, but it really does. Okay, that's why you've got to do the algebra. But you can kind of see that there's a part missing in the middle, which is right there, that there is not a graph. Again, there is not a shorter way to do this. You're going to set it greater than or equal to 0. Factor, set each factor equal to 0. Then we're going to do test points on a number line. Right? Pick numbers in each region, something less than -2/3, something between these two, and something greater. It's not that hard. You can use your calculator to help, but you still have to do the algebra. We've got some combinations of a lot of things. We've got a square root that's in the numerator, so I can set that greater than or equal to 0. But I also have the denominator that cannot be 0. Well, let's just put these together and see what happens. I have that. I could factor that, or I could just bring 25 to the other side and take the square root. Oops, and that's not equal to. Well, I'm looking at my picture. Let's look at this. Where is that on the number line? Here's 4. Here's 5. Here's -5. Okay, and that says it cannot be these two numbers. This says it can be anything greater than or equal to 4. Well, I have to put those two concepts together. So it can equal to 4, it can be greater than 4, but it can't be 5. So this -5 is not even in the picture. It has to be greater than 4, but it can't be 5. How do I write that? From 4 to 5, 5 to infinity. We should probably put a little union sign in between there. Kind of weird. And again, if you look at the picture, right, here's 4, almost to 5, there's a vertical asymptote, and then 5 and beyond. It stops right there. I had to really zoom in to get that picture. This one's really complicated. We've got that whole big fraction. And it has to be greater than or equal to 0. So this is just like a previous example, just a little bit yuckier numbers. So I'm going to take the top and set it equal to 0. I'm going to take the bottom and set that not equal to 0, cannot divide by 0, and I'm going to solve. Yuck. Look at that graph. That's kind of odd. Right, so let's see. I'm going to put all those numbers on a number line. So I have -square root of 5, -square root of 7/2, positive square root of 7/2, and positive square root of 5. So let's see. It can equal those numbers. It cannot equal those numbers. So I've got open circles. So how many regions do I have to test? 1, 2, 3, 4, 5 regions. So let's see. I'm going to pick something like -3. I believe that is smaller than the square root of -5. Now here, I really need to know what is the square root of -7/2. Okay, this is approximately 1.8, so I'm going to pick -2. And then anything between a negative and a positive is 0. Then I'm going to pick a +2 and a +3. And where am I checking that? Here. Okay, so if I plug in -3, squared is 9 minus 5, 18 minus 7. Yes, that's true. If I plug in -2, I'm going to get 4 minus 5 over 8 minus 7. That is not greater than 0. if I plug in 0, let's see, if I plug in 0, I'm going to get negative 5 over negative 7, which is positive. So that's good. If I plug in 2, positive 2, I'm going to get the same thing that I got with negative 2, and that doesn't work. And when I plug in 3, I'm going to get the same thing that I got with negative 3, and that does work. So yes, most of the time they do alternate, but you still got to check. Right, so we have from negative infinity to negative square root of 5 bracket, and then negative square root of 7 halves to positive square root of 7 halves, and then square root of 5 and beyond. So let's see, this part has got to be here. Remember, these were our vertical asymptotes, which kind of matches that, and then from the square root of 5 and beyond. So take your time, take your steps, and here are the key things. Radicand greater than or equal to 0 and solve. The denominator can't be 0, and again, those vertical asymptotes relate to where the values of x cannot exist.